at angles of polygons. So we should be looking at this side of our paper, right here, where it says angles of polygons classwork. And we are going to go through these. So the first thing we're going to do is state what shape each of these are. What's this shape right here?
Square.
What's the next one? Down. We're going to go straight down. Pentagon. Pentagon. It's got 5 sides. What's the next one? Hexagon. It has 6 sides. Ooh, this is a tricky one. How many sides does this next one have?
7.
It definitely doesn't have 8. It has 7. And so a 7-sided figure is called a heptagon.
This is the octagon.
And then the last one is an octagon. Shh. Unless you're answering my questions, if you could be quiet, that would be appreciated. Okay. Now we're going to do 3 things in this column on the right. We are going to find the central angle, the interior angle, and an exterior angle. Okay? The next box, we're just going to draw in our diagonals. Okay. So first, central angle looks like this. So what do we think? How many degrees is that central angle? 90 degrees. Make sure we're labeling it central angle. Okay. Right here, I'm going to draw a line. What do we think this angle is in the inside? This is my interior. What are the degrees of the square? Come on, guys. 90. This is an interior angle inside the square. What would this degree be out here? Exterior angle. 90. That's an exterior angle. Okay, we're going to draw the diagonals for the square. So we're going to go to the vertices. Who knows what a vertice is?
Then what is it?
It's 2 sides meeting. It's like the corner. Okay, and we're going to draw a diagonal to connect the vertices opposite. So you guys see how this has 2 diagonals? Yeah?
Mm-hmm.
Okay. All right. We're going to do the next one. This is a pentagon. And so we wanted to have a central angle. What do we think this central angle would be, or how would we figure it out? All right, we just did a whole unit on circles, right?
Yeah.
So let's say I surround that pentagon with a circle. How many degrees does a circle have?
360.
360. Okay, so if I took 360 and divided it up, how many am I going to divide this up into? 5, right? I just want to know one of them. So I'm going to go 360 divided by 5. So I get 72 degrees is my central angle. Okay. So central angles and exterior angles are the same. So this has to be 72. My exterior. All right, how am I going to find this interior angle right here? Subtract 180 minus 72, and I get 108 degrees is my interior angle. Right? And why did I use 180? Because it forms a what? If I just expand this line, this is all like what line? Straight line, and straight lines are 180 degrees. Okay, let's draw in our diagonals here. Here's my vertice. I'm going to draw 1 diagonal, 2 diagonals. Right? The rest are connected, so I can't draw them. Do you guys see the difference? This vertice only had 1 diagonal. A pentagon had 2. So I'm going to draw 2 from each of the vertices. Okay? So I've got 1, 2, 3, 4, 5 diagonals you're drawing. It is. Okay.
Don't need to brag.
Let's look at the, what shape is this again? Hexagon. Okay, what is my central angle going to be for this hexagon?
It's 60.
Let's see. That's
60 degrees, right?
Interior is 120.
Hold on, you're going a little fast for us, Will.
Oh, sorry.
It's okay. It's good, though.
I can't keep.
You
up.
can keep going, Will, if you want to work ahead.
Okay, I already did.
Good. Okay, that's my central angle. Right here is my exterior angle, which is going to be the same, 60 degrees. And then I go 180 minus 60, giving me my interior angle, which is 120. Now we're going to go, okay, if this had two diagonals, then I could draw one from each vertices or corner. This is a pentagon. I drew 5 diagonals, 2 from each corner. How many do you think is going to come from each vertice for the hexagon? 3. So I go 1, 2, 3 diagonals, right? Now I'm going to do it for every single vertices, right? So I've got 3, 4, 5, 6, 7, 8, 9. Okay, so remember I don't count them twice, right? So this has 3, so now each one of these will have 1 and go through it. So I have to count while I draw it or else I get messed up.
I know.
We'll do it when we see heptagon.
Hold up. Does
I
that
think
look
I'm
right?
just missing. Yeah, I just need to like on one line.
Give me one more from this one right here. Okay,
We'll take our right.
remember you're being recorded. All right. Next, we're going to look at a heptagon, 7 sides. Are we back together, guys?
Looks like
Okay,
a bunch of triangles.
heptagon. What is my central angle for my heptagon?
60 divided by
360 divided by 7, which gives me 51.4 degrees. That's my central angle.
That's also.
That is also the exterior angle. 51.4. So the interior angle would be,
That
180 minus.
which is 128.6. Okay. I could do 1 vertices, 1 diagonal from each vertice for a square, 2 diagonals from each vertice for the pentagon, 3 diagonals from each vertice for the hexagon. So how many from each vertice for the heptagon?
4.
4. Okay, I have to count them as I go. So watch me, I'll try to draw slow. Here we go. 1, 2, 3, 4. Now I'm moving to the next one. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
So like that.
Yeah, so like that. Why does
Okay.
yours look so much nicer?
What? I thought you were about to say words. Yours looks like
Alright.
it's like golden.
Let's move on to our octagon.
Oh no.
Oh, I'm scared for this.
Octagon. Okay, here's my central angle. So remember we did 360 divided by 8. What did you get?
45.
45 degrees
The
is my central angle.
exterior is 45,
Goodwill.
and the interior is 135.
The interior is 135. Good. Okay. So we did 4 lines from each vertice. How many? 5. Okay.
Oh god.
You ready?
No. Alright, can you draw it like
I
slow?
already know how this thing works now.
So we're gonna go
Alright, hold on,
1,
wait. Okay, here's 1.
2, 3, 4, 5.
Okay,
Now I'm going to the next one. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19,
So like you keep going until you can't connect the line.
Okay, let's turn it over.
Why are your lines so straight?
Because I don't be crooked like that. I don't know.
Look at mine straight in it.
Okay. This back part is very important because we come up with formulas. Do you guys see this chart? This little bottom part of this chart is the formulas that you will need to do tonight's homework. Okay, you ready?
Oh, yeah.
Okay. Number of sides, we've got 4. Measure of one central angle. So you might have to flip it over. What's the measure of one central angle? 90. What is the measure of one central angle for 5?
72.
72. What about for 6? 60. What about for 7?
1.
What about for 8?
45.
45. Okay, so the formula we've already discussed is 360 divided by n, number of sides. So if I had 100 sides, I'd go 360 divided by 100, right? Give you your central angle. All right. Measure of one interior angle. So for 4, the measure of one interior angle is?
90.
For 5, it's?
108.
108. For 6?
120.
For 7?
128.6.
And for 8.
155.
Okay, so this equation is a little bit harder to come across. But remember how we were taking away from 180 and all that? If we just look at the number of sides and we subtract 2 from that and then times it by 180 and divide it by the number of sides, we get one interior.
Whoa.
Okay. The sum of the measures of the interior angle. What's 90 times 4, guys? 360. How many angles does, if it has 5 sides, it has how many angles inside of it? 5. So 108 times 5 is? 540. Okay, what's about 120 times 6?
720.
Good. What about 128.6 times 7?
122.
What about 135 degrees by 8?
1080.
1080, good. Okay, this is almost like this equation, it's just n minus 2 times 180. Okay, measure of one exterior angle. Measure of one exterior angle. What column is this going to be exactly like?
First one.
First one. Okay, so 4 it's 90, 5 it's 72, 6 it's 60, 7 it's 51.4, and 8 it's 45. Okay? So that is just 360 divided by n.
So is this one just gonna be like?
It's the same as the first one. I think.
Okay?
About the sum.
Yep.
So you're gonna be the same.
Yeah.
All right. Sum of the exteriors. So if I added up all the exteriors, let's draw a picture real quick. Hold on. Here's a square. here are my exterior angles. They look like this. What are those all going to add up to be? 360, good. Okay, let's look at a pentagon. Let's look at the pentagon. Look at it. What are all of these going to add up to? All of these exterior angles are 72, right? And there's 5 of them, so it's going to be 360. All of these are going to end up being 360. Okay. Now, there is a formula for number of diagonals. I didn't really discuss it in my other classes because it's not super relevant. You don't super need it, but we can do it. Okay, so the number of diagonals for number 4 is 2. For 5 is
5,
for 6 is
9,
for 7 is
14,
and for 8 is
20.
okay. So the formula is n times n minus 3 all over 2. Okay.
Oh, I
All right. We are going to do the bottom. So these formulas right here you need. This is very important. I'm going to make sure that's still on the screen as I keep doing the other parts. Okay. What do the interior angles of a 4-sided figure always add up to be? 360. So I know these little squares mean 90. So 90 plus 90 plus 142 plus x equals 360. Okay? 90 plus 90 plus 142 gives me 322 plus x equals 360. Now I'm going to subtract 322 from both sides. So x equals 38 degrees. Does that make sense? Where did I get 360 from? The 322, 90 plus 90 is 180. 180 plus 142 is 3. Okay, let's do this next one here together, and then you'll do these two at the bottom on your own.
Oh, yay.
Okay? All right. This has how many sides? How many angles?
Too many.
1, 2, 3, 4, 5, 6.
It has 6 sides. So 6 sides, the interior angles add up to 720. Okay. So I'm going to have to list all of this. I'm going to have to say 5x plus 4x plus 2 plus 5x plus 6 plus 2x minus 2 plus 3x plus 5 plus x minus 10 equals 720.
That's what they're warning about.
Yeah.
Okay.
They're saying, watch out, guys.
So we're going to add all of the x ones together. So my x ones are 5x,
4x,
4x,
5x,
5x,
3x,
2x,
and x.
3x, and x, and that adds together to give you 20x. Now I'm going to add all the other ones up together, and I get 1.
1?
Yeah, because that minus 10 and minus 2 end up getting you down to 1. So I'm going to subtract 1 from each side, and I get 20x equals 719. Divide both sides by 20, and our x equals 35.95. But I'm not done yet, right? Because I've got that y right there. Do you guys see how this is not a regular hexagon, meaning the inside angles are not all equal? We agree that this cannot be the same as this angle right here, right? So we're going to have to plug this in. 3 times 35.95 plus 5 gives me 112.85. And then what do these two, when I add them together, what do these two equal? 180. So I'm going to say 2y plus 112.85 equals 180. So 2y equals 67.15 divided by 2 means y equals 33.575. Okay, I'm going to give you some time now to work on these next 2 problems.
Why was it so hard?
I want you to work on the next 2 problems.
So it would be x, or it would be x plus 14. Or is that 34? Correct.
If you have these, you should be good with everything else. If you would like to copy this for me.
What the heck is going on here? I don't know what's going on.
Okay,
I'm so confused.
so, ladies and gentlemen,
Well, I didn't get that.
we are going to look at this one down here. We agree that all of these 2 are x's, right? But the problem is we need to know what this angle is right here. So I start with going 180 minus 64, gives me 116. Then this has 5 sides, so I know it's going to add up to 540. So x plus 14 plus 116 plus x plus 90 equals 540. So I get 3x plus 220 equals 540. Subtract 220 from both sides. 3x equals 320. Divide by 3. I know it's fast, but we got stuff to do. X equals 106.7. Okay? The next one. We agree that all of these arcs are x, correct?
Correct.
Yeah.
Okay. We know that's 90 right there.
Correct.
And this has how many sides?
1, 2, 3, 4, 5, 6.
6, so it should add up to 720. So 1, 2, 3, that's 3x, plus 90, plus 150, plus x plus 10, equals 720. Okay. So 3x and x makes 4x. 90 plus 150 plus 10 gives me 250. Equals 720. Subtract 250 from both sides. 4x equals 470. Divide by 4, and x equals 117.5. Okay. These equations, these equations that you have, you need to apply to your homework. So let's look at our homework as soon as you've got this down to make sure we have the equations for the right places. We ready?
No.
I'm the coolest.
Okay. So,
Never.
right here, excuse me, this is how to do your homework. You want to focus. We need to find the measure of one interior angle in each polygon. Round your answers to the nearest 10. So if you look right under, find the measure of one interior angle. That's my equation right there at the bottom. N minus 2 times 180 n. So I might write that next to it so I know which equation to use. Okay? Those are for the first 10. For the next ones, It says find the measure, excuse me. It says find the measure of one exterior angle in each polygon. So which one talks about exterior angles? Measure of one exterior angle, so we need 360 divided by n.
So you're just counting sides.
Yep, that's what n means, the number of sides. Okay, let's turn it over. Okay,
What about it?
find the interior angle sum of each polygon. So which one says sum at the top? Okay, this one right here in the middle. So it's n minus 2 times 180. How many sides does a dodecagon have?
12.
12.
Someone's been doing that.
Number 29? All right, I'm going to stop the recording. We're going to spend the rest of the time working on our homework, and I'm going to pass out